ಝೂಮ್ ಮಾಡ್ಬೇಕಾ ಅಂತ.
Okay, now?
Yes.
Okay, fine. Okay, so let us begin the session. So last session, due to internet issue, we could not do it. We are just discussing a little bit, and then we had to wind up the session due to the network issue. So in the last session, I was talking about the WPC. See, in the ham radio, when we clear the exam, we have to apply for the license, and the license issuing authority was WPC, that is a Wireless Planning and Coordination Wing. And every ham who clears the exam will get a call sign. So my call sign is VU3PZL. Likewise, everybody will get the unique call sign. So the first, the maximum number of characters will be of 6 characters. So first 2 characters will be the country code, and the number, the numerical number here, it represents the grade. So if it is 3, then it is restricted grade. If it is 2, it is a general grade. And last 3 characters will represent some close relation to your name. Maybe, may not be always. It depends on the availability. So this will come in your examination. How many characters, maximum number of characters will be there in the call sign, in Indian call sign? If it is asked, then you can say the options will be there. So you can write 6. And what is the VU represents? So you can write it as the Indian code. Okay. So now let us head back to our basic electronics topic. So in the previous sessions, we have discussed about what is a conductor, insulator, and a resistor. So now we will continue our discussion with the voltage, current, and then we will try to relate this voltage, current with the resistance. Okay. So let us take a conductor. For example, let us take it, consider this is a copper rod. And for this copper rod, I'll apply certain voltage here, with the positive connected here, with the negative terminal connected here. So what happens is that the current starts flowing from positive to negative. So basically there are 2 types of voltages which we need to understand. So one is, you all know, we know the terminology, that is the DC and AC. So DC represents the direct current, and AC represents the alternating current. So DC means it is the direct current, AC means it is alternate current. So what is this DC current? I'll just give a small introduction here, then we will continue with our the conductor example. So this is the reference line, say this is 0, this is the time, and this is the magnitude in terms of volts. Now with respect to the 0 reference, now a constant voltage is maintained. For example, say 10 volts of voltage. There is no variation at all. The constant voltage is maintained. So this type of okay, sorry, I brought in 2 different things. Okay, let me define this as current itself. So current is defined by I. So say 10 milliamperes. So the current is what? The current is constant with respect to 0. Now, alternating current, in the sense, it is continuously varying in a form of sinusoidal waveform. So now what happens? The current here, it is a positive, and here it is a negative current. Now basically we call it as this is the DC direct current and the alternating current. Now with respect to this, the likewise the 2 voltage source exists. That is like DC current and AC current. We call it as a DC voltage and AC voltage. Correspond to that. So let us write the same conductor here. Let us connect to a battery. So this is a positive terminal of the battery, our DC battery, which we use in car and the mobile phones, and all these are DC batteries, which provides a direct current. So what happens? This becomes a positive and negative, and this considering the copper wire. And we say that the current is flowing from positive to negative. Actually, what is happening here is the electrons are flowing from negative to positive. Now the electron starts moving in this direction. So when the electrons start moving from from right to left, then it reaches from the negative polarity of the voltage source, that is the, let me write this as, let me give some name to this, I call it as V. Then the electrons will travel all the way from negative through conductor, and it reaches to the positive terminal. Why we are discussing this point is I'm trying to relate here the three terms, that is voltage, current, and resistor. I'll come to this point. I'll try to relate to these points later. Now first understand how the electrons are moving. Electrons always moves from negative to positive, but we always say current moves from positive to negative. So whenever we show the electron current flow, the movement of electrons, we call it as the electron current. And the conventional current is nothing but we call it as the Hall current. Okay. So let us understand a little bit in depth what is this means. Let us consider this is something like the chair. Okay. Assume this is a conductor here. This is a conductor. This is a chair. The chairs. This is positive and negative. I connected the voltage source. Now what happens? The electrons which come here at this point, let me call this as point A and point B of the conductor. So what is happening? The first electron gets occupied here. It means the chair is filled, and then it further moves here due to this potential. Now this is called as external potential. And how is this external potential exist? Because of the potential difference that is created between these two voltages, that is due to this positive and negative voltage of the battery. Now the electron comes here, and what happens? Now this has left its place. Now again what happens? This electron will leave this chair and come here or occupy this new hole. Instead of chair, let us call it as hole, and it occupies here, and it further moves. Now what happened? This, whatever I'm writing here, the minus sign, it is the electron. So it means the electron has moved from B to A. And in the same time, when the electron is moving from here to here, what is happening? The chair is getting vacant from A to B, correct? The chair is getting vacant from A to B. So it means the hole is moving from A to B. So we always represent the flow of current with respect to the conventional current. It means the whole current, but hole does not move. As you can see, these are holes. Okay. So this hole did not move. What is actually moved is the electrons. So electron has moved from one position to another position. It means it has occupied the empty hole, and it has keep on moving like this. And when it moves, it leaves behind the empty space or empty, yeah, you can call it as empty space, that we call it as the hole. So the actual movement takes place due to the electrons, but we always say the current is due to the flow of conventional current, that is due to the flow of holes, but actually holes does not move. Okay, this is just for our understanding. Now whenever Now we have taken an example of a conductor here. So conductor is the copper is a very good conductor. It allows the current to flow. So now forget about the electron flow current. Just to avoid the confusions, we will not consider the two different things. That is just for your understanding. Let me rewrite this. Now the current is flowing from positive to negative, that is from point A to point B, when we apply this voltage here. So the the current is moving at very ease because it is a very good, the copper is a very good conductor. So the voltage, when we measure the voltage drop across this point, will be very less. If you measure the voltage drop across this conductor, it will be very less. Every metal, everything, every matter will have certain resistance. Okay, so that resistance will restrict the flow of current. Either it will be restriction will be high or restriction will be low. Now let us take an example and understand here. I'll give a simple example. This is a road. Nowadays you can see that there are a lot of barricades that are put due to this COVID, and there are policemen who are standing here. Now the vehicles are moving here. The vehicles are coming in this direction. Say some 5 vehicles are coming. If there are no barricades here, what happens? These vehicles will move at ease without any disturbance, and the time taken for these vehicles to travel is very less. It means it will travel at same speed without any disturbance. But what happens if you put a barricade here at this point, and then policeman checks the vehicles and then it leaves? Then at that time, what happens? The lot of vehicles get piled up here. So it means if there are 5 vehicles are coming at the check post, all the 5 will be crossing. There is no doubt. But thing is that it is not traveling with the same speed. The speed has been reduced. So that you can understand as the resistance. These barricades as the resistance. And this traffic which is formed due to this barricade, you can consider it as the voltage drop. The voltage drop means the traffic has increased due to this. So now let us relate to our example here. So with the same example again continuing. So if this is a copper plate or a copper metal, anything which is connected, we applied the voltage source here. The current is flowing, but at this point it depends on the material, what type of material we are using. Since it is a copper, it is just like a highway without any traffic. The current easily moves, okay, from one end to the another end. The resistance offered is very less. The resistance offered will be very less. Whereas if you use another kind of material which has a very high resistance, then it takes a very long time. Now this resistance, we represent that in a form of a symbol like this. Why is this symbol given? Because you see, if I write like this, it's a very smooth curve and the current can easily pass. But if it is like this, it is just like your speed breakers on the road. So what happens when speed breakers are there? Then vehicle will take a lot of time to cross this point. So it means we are creating a kind of a resistance at this point. So that is why this symbol as the resistance is given by this symbol. So the resistance is represented by a character R, and this is the symbol of a resistor. Always it has to be written like this. Okay. Now let us introduce one law here, that is Ohm's law, with relation to this example of the conductor. Now Ohm's law defines the current flow can be defined as the voltage applied by the resistance, or The voltage drop across the conductor can be defined as the amount of current it is flowing and the amount of resistor it is offering. Now what is happen? Now just look into this equation here. Now what is R? It is a resistance. I is the current. V is the voltage drop across this conductor. Now if you want to understand what is the voltage drop, means what is the traffic that is being created, that depends purely on the resistance. If the resistance is too high, then what happens? For example, we have taken an example of the barricade and the check post. If the checking is very strict, it means they're checking each and every vehicle, they're stopping, they're asking to open the dicky, checking the luggage. Then what happens? There is a huge traffic which is piled up behind each vehicle. And if the checking is very easy, now they're just asking where you're going. Okay, you can go. If you just show the pass, you can go. So if the checking is very fast, then what happens? The traffic pileup will be very less. So considering the same example here, if the resistance is too high, then what happens? The voltage drop is also very high. If the resistance is less, then the voltage drop across the conductor is less. Is it clear? Hope it made some sense to you all. Are you able to follow this? Okay, thank you. So now this relation, whatever we have written here, it is called as the Ohm's law. Okay, and the resistance is always measured in ohms, and it is represented like this. This is the ohm representation. Now let us look into the relation here. Okay, I'll come to this point later. Resistance. Now you see the Ohm's law here. The applied voltage equals the circuit current times the resistance. The same thing we have written here. You see, V is equal to I into R. It is in the equation form. Now these things we can rearrange. Now we can also find the amount of current which is flowing depends on the voltage applied divided by what is the resistance, just by rearranging this. Okay, because in the ham radio exam, you will get some examples based on the resistance. So we have to understand this resistance. Now you understood what is the meaning of resistance. Now, it is not only about the conductor having a resistor, or a copper or a aluminum metal has a resistor. It depends. Now, for example, if the length of the bar is too large and it has certain width, and same width of bar is there, a copper wire, but the length is reduced. Now tell me whether here the resistance is more, let me call it as R1, and here R2. Now what is the resistance of R1 when compared to R2? Whether the resistance of this is greater or this, the R2 is greater. Which one is greater? As the length of the conductor increase, let me take the questions here. As the length of the conductor or a metal increases, the resistance increase or decrease? Guess, you can put across your whatever the guess or your understanding. You can type in the chat box. R1 has the highest resistance. That is true. Thank you. Why? Because as the conductor length increases, its resistance value also increases. That is the thing. Now there are few resistors which are made up of semiconductor material. In the electronic circuits, we have to use the resistance to restrict the flow of current or to obtain the desired voltage. There are two purposes. First one is we call it as a current limiting resistor. Current limiting resistor. Sometimes we have to limit the flow of current. And we also use in the circuits to get the desired voltage. Now, to get the desired voltage or to restrict the flow of current, we use the resistors in an electronic circuit. Now, let me connect a simple resistor here. Let me call this as R, and this is V. And the current, always we consider that it flows from positive to negative. So from the Ohm's law equation, I can write V is equal to I into R. So it means the voltage drop across this point is exactly same as, for example, if I apply the 10 volts here, then the voltage drop across this point will be 10 volts because of this resistance. So then if I know what is the current which is flowing, for example, if I say the current flowing is 10 milliamperes, then I can find my resistance. What is my resistance required to achieve this thing? Then R is equal to V by I. So I can just substitute here. So it is 10 by 10 milli. So I'll get a resistance of 1000 ohms. This 1000 ohms can be written as 1 kilo ohms. There are few terminologies which we'll be using, like 1000, we call it as kilo. Then 10 to the power 1, 2, 3, 4, 5, 6. This is called as mega. So it is something like this. It is mega. Mega ohms, kilo ohms, and mega ohms. Resistance are always will be in this range, or it will be in just in terms of ohms. Ohms, kilo ohms, and mega ohms. Okay. So rather than writing as 1000 ohms, we can write this as the 1 kilo ohm. Now let us introduce to, in this case, let us add the two resistance here. Now let me call this as R1. This is R2. There are two resistors which are connected. Now, I want to find what is the voltage drop across each of these points. What is the voltage drop across the resistance R1 and voltage drop across resistance R2. So this voltage drop, we can call it as V1, and this voltage drop, we can call it as V2. Now, how do we find this? It is very simple again. So it's the same equation. So I can write, see, understand one thing. This is called as series connections. Series means what? The two resistors are connected in series. Okay, let me introduce one more new thing here. Something called series connection and parallel connection. Okay. To make you understand, I'll take the same example of a copper rod. Now, two copper rods are connected like this. And the first end of the copper rod, let me give the terminology A, B, C, D. Okay. Is connected to some voltage here, positive. And the end of the first copper rod end, call it as B, is connected to the another end of another copper rod C, and the second copper rod, another end, that is D, is connected to the negative terminal of the battery. Now this has certain resistance called as R1. This has certain resistance called R2, because these are two different coppers. But all together, I can combine this. Because it is connected in series, then I can consider it as a single copper rod, which I can call it as R, which is equal to, I can write it as R1 plus R2. Because since it is connected in series, it's get added up. Its resistance get added up. Then I can write the resistance R is equal to R1 plus R2. Then I can represent like this with a single, like this. It's a representation. Okay. So this type of connection is called as the series connection. This is called as the series connection. Now in the series connection, we have to understand that the current flow will not going to change. The current flow will not going to change. If the current flowing here, if it is I, here also the current flowing is I. Let me give you the suitable example so that you can better understand. Let us come back to the same check post. This is called as check post 1. Okay. And after a certain distance, there is another check post. Say after 10 kilometers, there is another check post. This is check post 2. And it falls on the same road. There is no diversion anywhere. It's a single road. There is no diversion on the road. Now, if there are 5 vehicles entering on the road at some point A, then it comes to this first check post 1. All the 5 vehicles will be checked and they further travel, and all the 5 vehicles will be reaching the check post 2, and all the 5 vehicles will be crossing this check post 2. So what did we understood? Whether any vehicle get lost? No vehicle get lost. All the 5 vehicles which entered the road have gone through first check post and also have gone through second check post and exited the road. So likewise, the current which is flowing here, the amount of current which is flowing here in the first conductor and the second conductor will remain to be same. There is no change in flow of current because these are connected in a series fashion. Let me come back to the same example of the check post. Now, the check post 1, there is a circle inspector standing, and he's very strict and is doing very rigorous checking, rigorous inspection of all the vehicles. Check post 2, only some Havaldar is standing, and he's very easy man, and he just sees the vehicle, and by looking at the vehicle, he just allows the vehicle to go. Now, what happens with the piling of traffic? Where will be the more traffic? Whether across the check post 1 or check post 2? Let me take your answers here. Thank you, sir. What about others? Others able to follow? Only Venkatraman sir is able to give the answer. Okay, Gautam. What about others? You're able to follow? Yes. Okay, thank you. So what did you understood by this? So all of you are giving answer as check post 1. Thank you. So you're all giving answer as check post 1. Why? Because this is rigorously checked by this check post 1. It means the traffic increase here is more. Likewise, if we have the 2 different types of conductor here, so one with has one electrical property, another with another electrical property, then if this is with higher resistance, if this conductor with a higher resistance, then it restricts the flow of current. It restricts the flow of current so that the current flows slow across this conductor. But all the electrons, all the current will flow. But it restricts the flow. But here, the resistance is less, so with an ease, it can cross this. Means the voltage drop, when I say V1 and V2 here the voltage drop will be more because of the high resistance. Here, the voltage drop will be less because of the less resistance offered by the conductor. So let us come back to our circuit here. So now, if the 2 resistor values are same, for example, if I take it as 10 ohm, this is also 10 ohm. Now, what will be the voltage drop across the resistor R1 and across resistor R2? You can relate this to the police chowki example. Quickly give me the answer. Thank you. Venkatraman sir has said same. Yes, correct. So when the resistance value is same, then the voltage drop across the point is also same. So if we take an example of this check post, if the kind of checking happens at both the check post, if it is same, then the traffic piling is also of same. It is not going to be different. If the same amount of time it takes to check one vehicle here as well as at the second check post here, if the same amount of time takes to check one vehicle, then the number of the vehicles get piled up will also be same. Likewise, now let me change the value here. If this becomes 100 ohms, it means it is offering higher resistance. Now what happens? The voltage drop across V1 has increased, whereas here the voltage drop remains to be same, but it is less when compared to V1. Okay. Now, in your examination, it will come like this simple example to calculate what is the current which is flowing. They will give simple example like this, and they will ask you what is the current. Now, I told you the amount of current which is flowing will not going to be changed. Means if there are 5 vehicles moving, all the 5 vehicles will cross this both the checkpost. Now let me take this as 10 volts. The voltage applied is 10 volts. The resistance here is 100 ohms, and here it is 10 ohms. Now how do we solve this example? Let me write the same circuit here so that we can clearly analyze that. This is R2, this is R1, this is of 100 ohms, this is 10 ohms, and this is 10 volts. Now the question is, we have to find what is the current which is flowing in the circuit. Now to find the current, we have to use the Ohm's law. I is equal to V by R. You should remember this equation. You can remember any one form, the other form can be rewritten. V is equal to I into R. It means you can rearrange this equation. I is equal to V by R. Now since the resistance are in series, I gave this example here. If 2 resistance are in series, or 3 resistance, or n number of resistance are connected in series, we can add up all the resistance and we can represent it by R. So it means I can write I is equal to, the voltage applied is 10 volts. Now resistance is R1 plus R2. I can write this as 10 divided by 100 plus 10 ohms, which I'll get 10 by 1000. So when you take 10 by 1000, you will get 1 milli, sorry, it's not, so we'll get 10 and 10. So 1 by 10 is 1 divided by 100, we will get a current of 0.01 amperes. Remember, the unit of current is amperes. Yes, anybody has anything to say?
10 by 100, 10.
Sorry, sir?
Is it 10 by 100, 10?
It is, okay, sorry, my mistake. Thank you, sir. It is actually 10 by 110. Sorry, my mistake. So if you calculate, then what do we get? Let's see.
.009.
Yes, we'll get 0.09 amperes. And the unit of current is always measured in terms of amperes, and it is represented as capital A. Even in exams, the unit will also come. What is the unit of current? Current is represented in terms of amperes. And voltage is represented in terms of volts, V, represented in terms of V. So this is how we can calculate the current, or we can find the resistance, or we can find the voltage drop across each of these points. Now in the examination, you also get few things. I would have taken just a minute. Give me 1 minute of time. I'll be stop sharing the screen. Okay. So hope you all have seen this in your some electronic equipments, maybe in your TV remotes or in VCRs or all these. Have you all seen this? This is called as a resistor. Whatever we have written here in a symbolic way, in a practically, these are called as resistors. Hope you all have seen in the remotes or whatever, all the electronic gadgets has this is the fundamental and very basic component in any electronic circuit, resistors. Yes. So now each of these resistor has its value. You see this color code here? It has different color. It has some yellow, it's a violet, red. This has some red. It has brown, black, brown. Then again, it has brown, green, red. All these different colors are there. What are these? The color represents. So we have to understand the color coding of these resistors. So there is something called very good wife. Okay. We have to remember this BBROYGBVGW. So how do we remember this? It's very simple. We read it as BB Roy of Great Britain is very good wife. My teacher has taught me very long back this thing. It's a simple statement that we all have to remember. BB Roy of Great Britain is very good wife. There are other things also exist, the other way of remembering. Well, I find this is very convenient. So what is this? BB Roy of Great Britain is very good wife represents here. So let me write this here. This term I have it here. Okay. So why is this? What does this represent? So the first B represents the black. The second B represents brown color. Third represents the red. Next, orange, yellow, green, blue, then violet, then gray, then white. We have to remember these many colors: black, brown, red, orange, yellow, green, blue, violet, gray, white. That is why we cannot remember all these in a sequence. It has to be remembered in sequence. You cannot remember orange first, then yellow, then it will be a problem. That is why I have written this statement here. BB Roy of Great Britain is very good wife. Now, how do we remember? We have one B here, second B, R, O is there, Y is there. Of is a term which is just used for the statement. Then there is a G, then there is a B. E is again just a word which is used for support. Then there is a V, then there is a one more G, and there is a W. So we are interested in these letters only. Now what is the value of black? 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, white is 9. These are the numbering which is given for each of this color code. Now you see the colors here. Now we have to identify, with the help of these color codes, we can identify what is the value of this resistor. Now, for example, here we have written 10 ohms and 100 ohms here, 10 ohms here, 100 ohms. Now these 10 and 100 is represented in terms of color code on the resistor to understand what resistor we can use, and we can use it in the circuit. Now let us take the same example here. You can see how many bands are here, how many strips are there, color strips. There is 1 color strip, 2, 3 and 4 color strips. This last one, if you see in this resistor here, it is actually a gold. The last strip is always represent the tolerance limit. It means whatever the resistor that is manufactured, it is not perfect. Now, for example, if we say 100 ohms, then we cannot get exactly the 100 ohm resistor. It might be either 90 ohm, or it might be 110 ohm, or it might be 120 ohm. Always there is a tolerance limit. The last band defines the tolerance. Now let me rewrite this resistor here so that we can understand. So this is a resistor. It will be like this. All right. Now the first band is like this. Then we have the second color band. Then we have the third color band, and then we have the one more last color band. Now these 3 bands represent the value, and the last band represents the tolerance. Sometimes it will be 3 plus 1, sometimes it will be 4 plus 1. There are some resistors where we have 1, 2, 3, 4, and we have last. Now in this case, the 4 bands represent the value of resistor, and the last band represents the tolerance value. Okay. Now let us take this case here. Whether it is 3 or 4 doesn't matter. Now the first 2 lines represents the value, straight away number, or we can just write number. The third represents, it is, or third or the last before the color, before this last, this one, either this or this, will represent into 10 to the power of the value. Okay. Now let us take an example here. I'll write one resistor. Okay. Now let me take here red. Okay, I have red here. Let me take it as green. And what are the other colors I have here? Okay, let me take it as brown. Then the last one is the gold. I think I don't have the gold. Rather than gold, I'll write it as yellow, will not be appropriate. Let me consider this as the gold, and then I'll write it here. Consider this is a gold. Okay. Now from this chart, whatever we have written, B.B. Roy of Great Britain is very good wife. The first B is the black, brown, red, orange, yellow, green, blue, violet, gray, and white. It has its own values. Now here, there is a red color. So this red represents what? What is the value from the table? It is 2. Let us write it as 2. Next, there is a green strip. What is the value of green? It is 5. Let us write this as 5. Then there is a brown strip. What is the value of brown? Brown is 1. I told you always the last strip value should be 10 to the power of. So I can write this into 10 to the power of brown value is 1. So what is the total value it has become? it means the value of the resistor is 250 ohms. It means by looking at the color code, I can define what is the value of a resistor. And the last one represents the tolerance. There are three different types of tolerance. That is plus or minus 5%, plus or minus 10%, plus or minus 20%. Gold represents, means the tolerance limit between the values is just 5. Here it is 10 and 20. It means if I say 250 ohms, either it will be 248 ohms or it will be 252 ohms, maybe a 5%. If I'm not wrong, the 5% of this is somewhat like this. It means the resistance value will range between any of these values. 10% means the variation in terms of same thing, in terms of 10%. So did you understood how to find the, in the examination it will come. The color code of the resistance is this. What is the value of resistance, it will ask in the examination. Then you have to write, you have to find out the value of resistance in this way. Let me take one more example here. Let me write one more resistor example here. I want you to find out what is the value of resistance. Red, red, red. And the last one is some gold or whatever. You forget about the last one because that is of our least concern. We are not going to bother about the last one. Okay. Now, what is the value of this resistor? Kindly calculate and tell me. Let me take answer from you all. I'll be waiting for your answer. Yes.
22K, sorry.
Sorry?
2200.
22K.
22K.
Yeah. 22,000 it is.
22,000. Who is giving answer?
2,000.
2200.
Yeah.
Okay. So we got answers here. So let us see what it is. So first is 2. Again it is 2. And this I told you it should be 10 to the power of. So it is 10 to the power of 2. So what do we get? 2200. So this ohms, we can also write this as 2.2 kilo ohms. Fine. Yes. So everyone have understood. Very nice. Fantastic. Congratulations. Okay. Now we have understood the color coding. Hope you will not forget it. So please note down, write it in your notes, whatever you are preparing. Now, once we have understood the color coding, let us come back to our circuit. I'll just take once again the resistor values here. This is R1, this is R2. Now, how do we find the total resistance when they are connected in series? So R is equal to R1 plus R2. Correct? Yes, perfectly fine. Now let me introduce to one more type of circuit. I told you there are two types of connections. One is a series connection that we already discussed. Now let us go to this parallel connection. Now let me write the two resistors are connected in parallel. Let me call this as R1 and R2. Now, how do we find the resistance across this, the total resistance? When two resistors are connected in parallel, this is one point, say point A, this is point B. Now these are connected in parallel. So how do we find the resistance? Now in this case, it is not R1 plus R2. We cannot
1
write
by
it.
R1 plus 1 by R.
Yes, this is not correct. So what do we do is, here for a parallel case, we'll write it as 1 by R is equal to 1 by R1 plus 1 by R2. So as somebody has rightly mentioned, so we'll write like this. We'll write in a reciprocal form. Then If you cross multiply, we will get this R2 plus R1, and we can multiply the denominators R1 and R2. We will get 1 by R. So in short, if I want to find the actual value of resistance, R is equal to R1 into R2 divided by R1 plus R2. So if two resistors are in parallel, use this equation, that is R1 into R2 divided by R1 plus R2, or you can straight away substitute in this equation, and then you can find the reciprocal of the total value. You will get the resistance across the parallel. Okay. Now, is this clear? Because I'm slightly going to increase the complexity of the circuit. If you are comfortable with this, we can go ahead with the next circuit. Is it fine? Shall we proceed? Okay, no answers. Okay. Okay. So let us take simple example of this, then we will go to little complex circuit. Now, we have two resistors here. So same examples we will take. This is R1. This is, okay. So R1 was 100 ohms. Let me write the same values so that you will not get confused. This is 100. This is 10. Now to find the total resistance, if I want to find total resistance, means I am going to replace this two resistor with a single resistor like this. This is point A, this is point B. This is R. So what do we get here? So 1 by R is equal to 1 by R1 plus 1 by R2. So we can just substitute 1 by 100 plus 1 by 10. You can find individual, you can calculate individually, and you can write. So 1 by 100, we will get it as 0.01, and here it is 1 divided by 10. We'll get it as 0.1. So what do we get here? 0.1 plus 0.01. So we will get a value of 0.11. Sorry, this is 1 by R. So then I have to take the inverse of this. So then 1 divided by this answer, I'll get this is, the resistance will be of 9 ohms. Did you understood this? 1 by R is equal to 0.11 ohm. But when I take the inverse of this to find the actual resistance, then I'll get it as 9 ohms. Reverse. Is this clear? So if you understood this, now let us understand one more thing here. The very important concept which I'm going to bring here is now this is the point A, this is point B, this is R1 resistor, this is R2 resistor. Now what happens here? The current is entering. All right. The current is entering. Now in this case I have to take two separate examples. Now there is a road and there is a diversion. The two roads diversion. Okay. Diverted. Now this is one road. There is a check post here. Here also check post is there. And then after certain distance, again these 2 points meet each other. Okay. Now, the vehicles which are coming here, some vehicle, I'm not good in drawing. So the vehicles are coming here, okay, like this. Now I'll take the same example here. Here there is a circle inspector who is standing, and here Havaldar is standing. Okay, this is circle inspector who is again very strict, seems to be strict. And here some Havaldar who is standing. Now, there are two different roads to reach the destination from point A to point B. There are two different routes. Okay. One route is this and another route is this. Now, you already know the vehicles which are passing will already know that if I go in this way, there will be strict checking. But if I go in this other way, the checking will be very casual. So what do the vehicles will do? Most of the vehicles will go either follow this path 1 or path 2. Let me take your answers. Obviously, if it is already known, then you take the path 2. The vehicles will take the path 2 because the resistance is less. Correct? So most of the traffic will be flowing like this. But some unknown case, what happens? It will land up here. So why I'm telling you this is because here R2 resistance is 10 ohms. Here R1 resistance is 100 ohms. Since R1 has the highest resistance, the amount of current which flows here. So what happens here? The traffic is get divided, correct? Whether whatever the traffic went through this, whether same amount of traffic can you expect here? If there are 5 vehicles, if 3 vehicles went this way, then 2 vehicles went this way. You cannot say all the 5 vehicles have went across the same route. It has to be get splitted up. So it means when the 2 resistors are in parallel, the current gets splits. Then let me call this as I1 and there is I2. And most of the current goes through R2 resistor because it offers less resistance. And less current flows through this resistor, that is R1. Ultimately, at this point B, the current again I is a sum of I1 plus I2. Hope you understood. So the 2 points I wanted to bring in with respect to the series resistor and the parallel resistance circuit. In series resistance circuit or in a series circuit, what happens? The current will remains to be same. It will not get split, but the voltage will going to be dropped at different resistor values. But in the parallel circuit, the voltage remains to be same. Now what happens? How many vehicles are ultimately reaching from point A to point B? It is same. If there are 5 vehicles, then all the 5 vehicles will reach here. Understand? So what happens? The voltage drop across the parallel element will be same, but the current gets split up. Hope you understood this point, because this is very, very fundamental in an electronic circuit to understand. When do we use? Because we need to understand when we have to use a series circuit and when we have to use the parallel circuit like this. We have to understand when there is a need to split the current, then we can use a parallel circuit. When we need to drop to obtain the desired voltage, then we can use the resistors in series and obtain the desired voltages. Now, since we have understood this concept, let us take a simple example here and to make you understand how to calculate the total resistance. Now there is a resistor here. This is R1, R2, R3, R4. Now question is, what is the total resistance of the circuit? How do we find the total resistance of the circuit? Can anybody answer it here? Let me take your answers.
Let them answer.
Yes.
Can I expect some answer here?
R1 plus R2 parallel R3 in series with R4.
Okay, so how do we start solving? From which point we need to start solving?
First solve the parallel circuit.
Okay, fantastic. Thank you, madam. So first what we will do is that we will first find the resistance of total resistance which are in parallel. So first we will find 1 by R2 plus 1 by R3. It means, in short, this will give us is nothing but R2 into R3 divided by R2 plus R3. We will get some, let us call this as R23 resistor. Then we are going to substitute this in this series resistor along with the other two. So we have this R1, then R23, then R4. Now ultimately you're going to add up all the three resistors, that is R1 plus R23 plus R4. So then finally when you add all these values, you will get the answer. Now let me give some values to these resistors. Say this is 100 ohms, this is 120 ohms, this is 300 ohms, and this is 500 ohms. Can you please calculate and tell me the final resistance value? This will be your small assignment for the day. If anybody has not understood this, you can ask the question. I'll keep the session open for question and answer. I think all are busy in calculating the value. Did anyone get the answer? Okay. So we have 600 ohms, 685.7. Okay. Let me ask you one more thing. I'm an electrical engineer, so I'll keep myself in background till you start radio propagation. Okay, thank you. Okay, fine. So now let me ask you one question. Did you all use calculators? Okay. In the examination, you're not supposed to use the calculator, so you have to practice without the calculator. Okay. So anyway, not a problem. You understood the concept. You can work out without calculator later. Okay. So shall we continue or should we stop at this point? Okay, I think it's too much for the day. So we will wind up our session. So I'll give few more examples to you to solve. I'll give one circuit to you. You can take this as you can use calculator for this because I'm just giving you this is going to be a little complex. Now I want you to find the current I1, I2, I3, then I4, I5, then I6. Okay, so this is the assignment. Kindly note down the circuit. So we'll continue in the next session. So in the next session, we're going to talk about the capacitors and inductors, because there is again the passive elements, passive components of the electronic circuit, and are very important in any electronic circuits, because when we talk about any communication device, we need to have an oscillator and an amplifiers. So capacitor and inductors are used to generate the oscillations. I'll discuss you these things in the coming sessions, and how we can use the capacitor and inductor to generate the oscillations, and why do we need oscillations, all these things. Okay, thank you everyone for joining today's session. Hope you will continue to join in the next session. Okay, there is, I think, some question. Vishwanath sir, you have any question?
ನನಗೆ ಮೊದಲನೇ ನಿಮ್ಮ ಪ್ರಶ್ನೆಗೆ ಉತ್ತರ ಅದ ಎಕ್ಸ್ಪ್ಲೈನ್ ಬೇಕಿತ್ತು.
Which example, sir? This one?
Yes.
Okay. So what do we do is here, first we will solve this circuit, this part. And how do we solve? By using this. I told you that the resistors, when they are in parallel, we use to write in this fashion: 1 by R plus 1 by R. So when we write this, we can directly substitute the value of R2, that is 120 ohms in the denominator, then 300 ohms in the denominator. Then we can simplify, and we can take reciprocal of it, inverse of it, and we'll get the value of R21. Now, for example, let me solve this here. So 1 by 120 plus 1 by 300. So this is equal to 1 by, I'll write this as, I'll give some name as R21, because I'm finding the value of R21 equivalent resistance. So 1 divided by 120. We can calculate and write the value, or we can substitute in this equation. Where is my cursor? Okay. We can also substitute in this equation. So I'll get 120 into 300 divided by 120 plus 300. This will give me the straight away answer of this. When we substitute and calculate, I'll get 85.71 ohms. Now what I will do next is, previously we had parallel circuits, that is R2 and R3. Now this parallel circuit is replaced by an equivalent circuit. We call it as an equivalent circuit. This I name it as R23, and its resistance value is 85.71. 85.71. Now R1, we know its value is, what is the value of R1? Yeah, 100 ohms, and R4 is 500. This is 100, then R4 is 500. Now we are going to add all these three. So what we are doing is, this parallel circuit, we are replacing it with the equivalent circuit with a simple single resistor value. That is what it means. And now we are going to add up all these values, which gives the value of whatever I have written here, that is 685.7 ohms. Is it clear, sir? Or still I need to?
Yes.
Okay, fine. Okay then, thank you all. Take care. Goodbye.
Bye. Thank you.